We will start our presentation today on my first talk, which is on overview of cryosphere and global distribution of snow and ice masses. Um, this lecture generally gives you overall view of cryosphere and it also gives you how it is distributed globally as well as in Himalayas. So the key question which many of you who are living in South India or a peninsular part of India or Indo-Gangetic plain must be wondering why there is snow on the earth. Hmm. And predominantly earth is a blue planet. That means mostly it is ocean and it is water, and water in the form of liquid uh, provides you a blue tone to the earth. So it is generally called as a blue planet. But if you really look into this issue, the triple point of pure water is a 0.01 degree Celsius at particular pressure, but it is atmospheric pressure. So you can see here, this is a triple point of water. What it means that water can exist in this at this temperature and pressure in a liquid form, in vapor form, as well as in solid form. And sometime, if you really look into the Earth geography, at some point of time, large region in Himalayas or large region in Europe or in Siberia or many other parts of the globe, this could be lower than 0.01 degree Celsius. In addition to that, it could be higher in southern India or polar regions, and because of that, it could be really in a liquid form. And as you go into the atmosphere, it could be also meeting much higher than that and causing in vapor form that particularly clouds and other we see. So in that context, the water is a unique because it can coexist for a given temperature and pressure condition of Earth in all three forms, the solid form, liquid form, and vapor form. And that is why we have a large part of Earth which is covered by snow and where the temperature is below 0 degrees Celsius, at least some part of year, or sometime it could be throughout the year, but at least some part of year temperature will be lower than 0.01 degrees Celsius, and the region where the temperature is below freezing is known as the cryosphere. So that is a huge cryosphere on the earth where water is in solid form. There are various forms of cryosphere, and this includes the seasonal snow, then there is the sea ice, then there are ice shelves, then there are ice sheet, glaciers and ice caps, permafrost, lake and river ice, and ice crystal in atmosphere. Some of these we are going to look in detail in this talk, as well as we are going to look in detail in subsequent talks also. And why it is important, why cryosphere is important, because it produces the meltwater to rivers, and this is particularly true to the India, particularly the river systems of North India, where they predominantly receive water from snow and glacier melt, and they are they are doing that. Then it is also very sensitive to climate change because you know that the snow and ice is very sensitive to the climate change. As temperature rises, it melts very fast. Because of that, we know really what kind of climate change is taking place on Earth, and this is very sensitive to that. This can also significantly change the sea level, because we already know that large part of water is stored in Antarctica, and if it melts and comes into the ocean, then it can significantly increase the sea level. There is also water, large amount of water is stored in the Greenland, and if Greenland also melts, as well as there are certain amount of water is stored in mountain glaciers, particularly Himalaya, Alps, Rockies, and Andes. So all this water melts, it can significantly increase the sea level and affect the many coastal cities and significant amount of our economy. It can influence the life on Earth, essentially because it is providing life will move around the cryosphere in such a fashion that it depends on it, and the societal activity can be significantly affected because of that. Some of those issues we will look into critically in a due course of time to understand. Yeah. Can you mute your hello? Is there any issue? So the cryosphere is not only a sphere on the Earth. It is interconnected, and it is interconnected with the various spheres. That means it is hydrosphere, that is the water, then atmosphere, and then of course cryosphere and biosphere and lithosphere. These are all spheres on Earth which is interlinked each other, and they're linked. Particularly cryosphere linked with the biosphere quite significantly, and the lithosphere. So it is important for us to understand the cryosphere is an integral part of the Earth system. But if you really look into how it works as a water cycle, so we already know that we have 97% of water on the Earth is in form of ocean, 2% of snow and ice, and only 1% of water is usable to us. So how important it is for us to preserve our usable water for sustaining human civilization, I really don't have to emphasize, you can understand. But let us, for those of you which are not very familiar with the concept of water cycle, how it works, I would like to spend 1 minute or so in that. So you have basically large ocean where because of the solar radiation, there is evaporation, and as it evaporates, it goes up into the atmosphere and it gets the condensation, and it gets transported. And once it's transported into the land mass, then either it can form as a precipitation, and that means it can either in form of snow, or it can be liquid water. It can precipitate, then is deposited onto the land surface. Then there is a runoff, and sometimes there is a sublimation. Is also there. That means sublimation means the solid form of ice and snow directly converts into the gaseous form, and then there is a sublimation of that. Then some of that snow melt, snow start melting, and it creates this old snow melt runoff. It enters into the land, and it goes into the rivers and ponds, and it can cause the evaporation. So you have two places evaporation: the water body which is on the land, and water body into the ocean. And in addition to that, some of that water can infiltrate into the ground, and then it is by evapotranspiration, this water can really enter again into the atmosphere. Or that groundwater can really enter into the river system, or it can go into the ocean directly. And so there are surface flow, and the rivers are formed. So This is a complex system by which water sometimes originates from the ocean and returns back to the ocean through the various processes, and this is known as water cycle. It is important for us to understand this. So it is also important for us to understand how Earth's water reservoirs are. So if you can really look into that, ocean has around 97% of water which is stored into the ocean. And we know that it is a 2000, around 2,260 meter is the mean thickness of ocean, and it is a transit time, general mean transit time into the ocean is 3,000 years. That means once water enter into the ocean, it takes around 3,000 years to come out of it and come return back to the atmosphere. If you look into the ice, which is just 2.5% of water, and mean thickness is 59 meters, that means if you really consider the mountain glaciers and many various other glaciers, so it is. But you can look into the mean transit time, which is 8,600 years. This is very important for us to understand that it takes very long time. Once snow falls onto the glaciers, it slowly gets converted snow into the ice and it start transporting and it start moving. And after a long time it melts, so therefore it has very long transit time, 8,600 years. The groundwater has also, it is a very small fraction, but it has also 5,000 years. On the contrary, if you look into the surface water, which generally has a 1 year transit time, and atmosphere is the shortest one, which is generally within 10 days, it can move from atmosphere to condensate and form a cloud and snowfall. It can, or rainfall, it can happen. So generally, water stays in atmosphere for a few days. So you can understand, once you remove this ice, whatever water is there in ice is stored there for a very long period. And if you remove that, then obviously it is going to come into the ocean or it is going to come into the atmosphere. So it is very important for us to understand the role of cryosphere, particularly glaciers, in managing the sea level. So if you really look into that, you already know that 97% in oceans, and it is saline, which is not available for significantly for the day-to-day human consumption, even though there is a blue economy and significant amount of resources of oceans are being used. But out of this 3% fresh water, you have 68% stored in the form of ice caps and glaciers. 30% is stored in groundwater and another is 0.9% and 0.3% is in surface water. And out of that 0.3% of surface water, you have 87% lakes, 2% in river and swamp. So you can really understand that how little water is available into the river. So, and it is important for us to make sure that we do not really significantly create dark water sources polluted to avoid the sustainable living onto the earth. But when we were looking onto the cryosphere, we can see there are a couple of components. We have seen many components of this. But one of the components of this is the seasonal snow cover. And what seasonal snow cover means is that winter there is a snowfall and large area of earth is covered because of the snow. And then that snow melts and disappears during summertime. So snow cover is the largest single component of cryosphere, covering an average area about 46 million square kilometer each year. So this is really a significant amount of land, at least some time in a year is covered by the seasonal snow, and 30 to 40% of land surface is created, is covered by the seasonal snow. We are extremely fortunate here in Himalaya also. We have seasonal snow, and particularly in many states like Jammu and Kashmir, Himachal Pradesh, Uttarakhand, Sikkim and Arunachal Pradesh, we are extremely lucky to have a seasonal snowfall there. And the many rivers such as Ganga, Indus and Brahmaputra receive this snow melt water. And this is very unique ecosystem where you receive snowfall in winter, but it melts in summer. So the snow melt is always slow. It is not like a monsoonal precipitation where it takes place very quickly and it melts and it runoff takes place very quickly, and you have much higher danger of a flood during monsoon time. However, snow can create some other types of risks for human civilization, but we will discuss that later on in that. So it is important for us to understand now we are moving to the glaciers that there is a large 11% of land surface is covered by glacier. Either it is in Antarctica, whether it is Greenland, whether it is Arctic region, whether it is the mountains of Himalaya, or whether it is Rockies, or whether it is Andes. So either they are in mountains or they are in a very cold region, polar regions. You can see large amount of glaciated terrain. So we will discuss what makes these glaciers, but it is important for us to understand where are the potential locations of the glacier. We already know that in order to form a glacier, you should have a winter snowfall which is higher than the summer melt. And that is only possible in high altitude regions, and it is a low elevation, or it is a low altitude regions with a high elevation. So if you really look into this issue, if you see the snow line, which is a permanent snow line, and that means the snow line which is above which snow can remain for throughout year. So you can see from South Pole, which is very low altitude, and it goes up. So if you have around 30 degrees north or 30 degrees south, there's a dry region, so the snow line goes up, and in the humid, in equatorial region, snow line comes significantly somewhat down, but you require, which is around a 5,000 meter snow line, or you require a land which is above the 5,000 meter, and that is why we do not have any glaciers in Western Ghat. Annamudi Peak is one of the highest peak in the Western Ghat, and we do not have, because we miss by whisker, particularly in southern region, that we were a little bit lower than that, 5,000 meter, and making it. But we are fortunate when it comes to the Himalayas, our altitude is much higher. And if you really look into the Himalayan monsoonal precipitation and other precipitation, in this region we have a land which is above 5,000 meter, and because of that, we have a large amount of glaciers in the Himalaya. So ice masses, there are numerous ice masses in Arctic part of world. That means you have Arctic land in northern Europe, Canadian Arctic island, Greenland. So if that all water, particularly located in Arctic part of world melts, then snow level can rise up to 7.2 meter. If you come to the southern part, which is Antarctica is there, if it melts, sea level can rise up to 65 meters. So you have polar regions, one is the northern pole region and one is southern pole region, where you have a lot of ice and glaciers. But you must be wondering, if we come into the north, the Arctic Ocean is also there, and this ocean is predominantly covered by ice. So if it melts, why sea level will not rise? And that must be questioned. I will not answer that question for you now. I would like you to dwell on this to find out why ice melt in Arctic will not change the sea level. So another issue, another region where the large amount of glaciers we can see is the mid-altitude region, that means around. So we have Iceland, Norway, Alps, Himalayas, Karakoram, Tibet, Alaska, Pacific Coastal Range, Patagonia Mountains, New Zealand, all these regions there are glaciers. But remember, these are nothing but the mountain glaciers. And they are relatively small glaciers because the topography controls their distribution. Since the topography controls their distribution, mountains are undulating, they have small region. It is not like a huge ice sheet like Antarctica and Greenland. But if it entire mid-altitude melts, sea level can rise by 0.5 meter. You may think it is not big, but it could be a big because it can really create serious problem for numerous tectonic region of the world, and which is generally a prosperous region because that is a prime agricultural land for many communities. In addition to that, these glaciers, particularly because nobody is living in Antarctica and very few people are living in Arctic region, but large population centers are around the Himalayas, Karakoram, around the Alps, Iceland. Also, there are then the Rocky Mountains receive significant amount of water, which receives in California as well as desert region of Nevada and numerous mountain communities and Patagonia too. So numerous communities depend upon water, and because of that, this is very important for us. In addition to that, you will be surprised to know in tropical regions also there are glaciers, and you can see there are not large, but there is definitely some amount of glaciers is there in Kenya, Uganda, Congo, Kilimanjaro, Mount Kenya, New Guinea, Indonesia, even in Ecuador, Bolivia, Venezuela, Chile, and northern Antilles. So many of you must be thinking that glaciers are located either in the Himalayas or located in polar region, but it is not so. They are also located in tropical regions, and you might not have thought that places like Kenya and Uganda you can have ice masses, and that is why I have given this slide to you, that glaciers in Africa. So there are numerous locations you can see, particularly about the Kilimanjaro, and I was just talking to you about this is exactly on equator. If you see, this is the equator, and this mountain, Kilimanjaro mountain, is on equator. So earlier slide where you see you required a land above 5,000 meter, and you can see here there are peaks. Kilimanjaro peak is at 5,895. Kenya, Mount Kenya around 5,200 and 5,100. So all those things making, even though the size is very small, but there are glaciers in that, and there are certain Pleistocene glaciations is also there. We will discuss this some other time, not at this time. But it is important for us to understand that we can have glaciers even in tropical region. If you come to the subtropical region, and particularly context of Himalayas, if many of you have traveled, and I'm sure many of you would have traveled, there are generally glaciers are located around the mountain ranges. As you move from Indo-Gangetic plain towards north, you generally have a Shivalik mountain range, and there are no glaciers in the Sivalik mountain ranges, but as you move to the Pir Panjal mountain range, and both the flanks of Pir Panjal mountain range, you have a lot of glaciation. Whether it is southern slope or northern slope, you have plenty of glaciation. Glaciers is there. Then, if you move further north, there is another mountain range which is Pir Panjal mountain. Sorry, it is a great Himalayan mountain range, and you can also see significant amount of glaciation there. But within that, see, if you move into the Pir Panjal mountain range towards the Great Himalayan mountain range, in between there is a valley and there are very little glaciation in the valley. So it is very important for us to understand the topography significantly influences the occurrence and distribution of glaciers. As you move further north, then there is the Ladakh mountain range, and eventually at the end, further north, the Karakoram mountain range. You know, all those things are really highly glaciated terrains in Himalayas. And we are lucky in a sense, like from this terrain we receive numerous rivers such as Indus River, which is originating into Tibetan plateau to enter into the Jammu and Kashmir and eventually going into the Pakistan. You have Ganga river, which is originating from Uttarakhand and then going through the Indo-Gangetic plain, Uttar Pradesh, and going into the Bangladesh and eventually to the Bay of Bengal. And then from Manas Sarovar, the Brahmaputra river originates and then enters into the Assam, Arunachal Pradesh, Assam, and eventually through Bangladesh. So this is many of these. We will discuss this issue in depth. How dependency of cryosphere is on water availability of these rivers. We will discuss that in due course of time. In addition to that, we have also looked into the sea ice. That means large part of Earth is also covered by sea ice, and particularly one which you can see the sea ice in Antarctic, in Arctic region. This is the Greenland, and this is the Arctic region. You can see large amount of sea ice there, and it is significantly changing. There is also large area under permafrost. Permafrost means subsurface matter which is below the surface that remains at or below 0 degrees Celsius continuously for at least 2 consecutive years. If we meet that criteria, then it is considered as a permafrost region. Permafrost provides or creates a unique challenges for the people living in those regions. We may not discuss that in depth there, but we have approximately 10% of land surface on the earth is covered by the permafrost. So in that sense, it is important. It is also important for us to understand ice on lakes. This is one of the Pangong Lake you can see, and many times this is located in Ladakh, in high altitude lake, and that lake really sometimes freezes and creating ice on its surface. And there are major ice masses in northern hemisphere, and that is the Greenland ice sheet. You can see is a large ice sheet, and this is a remnant of Pleistocene glaciation. And in addition to that, their polar sea ice is also there. The southern hemisphere, also there is a huge Antarctic ice sheet, and you can see that southern pole and the whole region of Antarctica is covered by significant amount of ice. So there is a different morphology when it comes to the ice masses. It means how it flows. It's quite different, and if you come to the ice sheet, we already discussed there are 2 major ice sheets are there. One ice sheet is in Antarctica and another ice sheet in Greenland. So if you see from the top and radially, you can see it has a center, and it radiates in all directions. The flow of ice goes into the all direction. This is very important for us to understand. And if you take the cross section, then you can see from center it flows. So initially it goes down and then slowly it moves from the bottom. So this is very for us to understand. However, it is also possible that this ice sheet can enter into the ocean. This can still anchor to the land and it creates the sea. So it is also possible to have this kind of phenomenon. So most of the glaciers which are located into the Himalayas, their ice masses constrained by the topography. That means you have a peculiar area which is a valley which is created by the tectonic activity, and these valleys are filled by seasonal snow, and eventually the seasonal snow will get converted into ice, and if the sufficient mass of ice is created, then it starts flowing and then the glacier is formed. And it has a very different movement which you can see, and we will dwell on this issue very differently. So looking into the glacier morphology, you can really look into what it means to understand. So you have ice sheet. On the earth, there are only two ice sheets as of now, and they are in Greenland, Antarctica ice sheet. Ice sheets are nothing but very large, extremely large ice, and its movement is not constrained by the topography. That means it is such a huge thickness that underlying topography is not influencing its movement. And there are certain ice caps, there are 70 ice caps on the globe. They are located, ice caps are nothing but the relatively small, but they are on the plateau, either on mountain plateau or, so there are certain seven. So there are ice domes and ice strips. Then there are marine ice masses, which is called ice shelves and ice rises. And then there are glaciers, which is constrained by topography. There are almost 2 lakhs glaciers, which are mountain glaciers or glaciers constrained by topography are there globally. I am not sure this is the correct number, but this is generally floating around. And you have ice fields, transactional glacier, valley glacier, Piedmont glacier, Sirk glacier, niche glacier, glaciers, ice apron, ice fringes, and rock glacier. We will look into this issue subsequently with time. But let us understand the flow of ice sheet, because this is very important for us to understand the flow of the ice sheet. And why? So you can see that this is a major ice sheet. Either it is Antarctic or Greenland ice sheet. So you have a center which is accumulating snow, and it is floating in this direction like outward direction towards the base. So what it means, because this understanding is very important, because you know that ice sheets are generally used to reconstruct the paleoclimate, and that context is very important for. If we don't understand it's the flow, and suppose you want to take the core into the ice, and if you come onto the margins, so it is quite possible that you may not get oldest ice. You can see here, if you take over here, you may not get the oldest ice. So if you really want to get the oldest ice, you have to understand the flow direction and then figure out where the oldest ice we can see. So that way it is very important. The large slab of ice floating into the sea attached to the largely fed land-derived ice. So you can see in Antarctica, and this is ice flow, then ice shelves are there, then eventually This because it is still anchored with the land, and therefore it is called ice shelves. And it is some of this portion gets carved out, and icebergs are formed because of the ocean activity. Vantagical ice cap, which is in Iceland, you can see how these are small ice cap, relatively small. But it is a dome-shaped glacier covering. It is a 50,000 square kilometer area, but it is flowing radially. What it means is you can see that the ice flow in this direction, this direction, this direction. So this is floating in all the directions. So it is important for us to. There are some ice sheets on there. Then there are tidewater glaciers. So tidewater glaciers means glaciers that terminates into the sea. This is a large glacier. It is entering into the ocean and it terminates into the. So its melting is a significantly influenced because of the ocean current as well as wave action. So numerous other parameters that non-tidewater or general glaciers you can expect it. So it is important for us to understand the. Then there are icebergs. This is the loose ice masses floating into the ocean, which is caused because of the calming. And then there are ice fields, which we have discussed about. So you can see these are the small ice fields, interconnected mass covering an alpine topography, flow pattern largely covered by underground topography. So topography influences how this will flow. Now we come to the idea of valley glaciers. Valley glaciers, this is one of the glaciers, Samudra Glacier, located into the Himachal Pradesh. And here the glaciers bounded by walls of valley and descend from the mountains. You can see that the glaciers is floating like this, but these are the mountain walls. These are the mountain walls. So glaciers cannot spread horizontally more than due to its constraint by valley. So it is important for us to understand that, and it moves from higher reaches to the lower reaches. What is really that perennial ice mass is all about? So if we can summarize this, and this is relatively recent work done by Marshall, you can see the Antarctica ice sheet has approximately 13 million square kilometer area, and it has almost 25 million cubic kilometer of ice, and its mean thickness is 1900 meter and maximum is 4000 meters. That means at some places Antarctica ice sheet could be as deep as 4 kilometers, and it has if it melts completely, it can raise the 56 meter water equivalent. Remember, these numbers keep on changing from work to work because over a period of time there is a significant underestimated or lack of knowledge is really giving these estimates not very accurate. The Greenland has 1.7 million, and it can raise. It has around 3,000 meter maximum thickness, and it can have raise a 7.1. There are mountain glaciers. It is around 1.1 million square kilometer area is covered, and the mean thickness is varying from 200 to 300 meter, and maximum thickness is around 1,000 meter. And we have such glaciers very close to 1,000 meter, like Siachen in Karakoram, and there is a permafrost. So this is how overall idea about the cryosphere distribution globally. The importance of cryosphere is also because it is important for us to understand that cryosphere, snow and glacier, particularly Himalaya, is very important because it is used significantly for hydropower generation. We know that there are huge hydropower plants in Himalayan region, and it is considered a green source of power Then it is used significantly for irrigation. So most of the green revolution of India, particularly Punjab, Haryana, and Western Uttar Pradesh, came because of the irrigated water which is coming onto the Indus and Ganga River, where predominantly coming from snow and glacier melt. And of course, the tinting is important. The glacier melt, here also I would like to say that the seasonality of snow and glacier melt is extremely important because most of the time in India, we live in the tropical region where predominantly snowfall occurs in a monsoonal time, but this snow and glacier provides us summertime this water and creating, making these all Himalayan rivers perennial. Otherwise, they would have been seasonal streams like what we have in southern India. The glacier melt, it contributes significantly to the sea level changes. The cryosphere also creates the hazards. It can create avalanches or flood. We have seen the recent flood in Uttarakhand, in the Rishiganga Valley, is one of the prime example of hazards, and it can come with or without warning, creating a significant loss not only of human life but human property. And it can also create the iceberg, and we have a very famous movie made out of it, and it can create the hazard for us. In addition to that, it can also modulate the climate. It has the albedo effect. That means many of you have seen the snow, which is extremely white, and it means that it reflects most of the incoming solar radiation. And if the snow is suddenly removed from the Earth, that means Earth is going to absorb most of the incoming solar radiation, depending upon the albedo of rock on which it is going to fall. And it is changing the climate system of the Earth. So it is very important for us to understand what effect it will create on climate due to modification of albedo. The paleoclimate is also, because as I was discussing earlier, it keeps the record of past climate. And there are many of you would have seen the fantastic record of how in past, how the temperature and other aspects of climate has changed over a period of time, and we could understand that very well by studying the cryosphere, particularly after taking numerous ice cores and studying landscape, erosion, landform. It can affect the ecology of the region. If it really, this is one, if there is this is an old slide, I don't think there are significantly changes have taken place, but if there is a 4-degree rise in temperature, then what will happen? And if the 2-degree rise in temperature, what will happen? This is in Mumbai, and this is the Chhatrapati Shivaji International Airport, and this is very famous fort area. You can see most of this area will be inundated if 4-degree rise in temperature, and this 2-degree rise in temperature means your airport will be not operational, and then significant prime land will be lost into the ocean. So it is important for us to look into the impact of changing climate and cryosphere and what it will have effect on ourselves. So with this thing, I would like to stop here.